This is EGR 103, the design process for military engineering, Part 2, Design Outputs. Okay, we're back, and we're going to complete this discussion of the design process for military engineers by talking about the second part, the design outputs, which is where I've spent most of my time when I was either in the military or working as a military contractor. The very first part of this is to synthesize the final design. Far and away, this is the most time-consuming of all of the activities. This involves the most time and the most people. This is where the detailed design takes place. So you can see there on that battleship turret that there's a lot of detail. You can think of every single part down to the smallest fastener is detailed in some way during this stage. So we start by producing the schematic drawings, the high-level drawings, for example, of the electrical and fluid systems. Also, any type of material transfer, such as for a system like this, we're moving powder and shells from place to place. So that would be worked out in the schematics. Then from that, we start the detailed diagrams, such as wiring and piping. And then we move to things like the structural elements. Ribs and stringers of aircraft are examples of structural elements. In this drawing of the battleship turret system, that would be the actual, what they call the barbette, which is the armored casing this turret fits in, as well as the gun house, which is the armored top level of the turret. We also produce interface drawings because all of these parts are interfacing together. We produce assembly drawings that tell the builders how to put it together. Obviously, we're providing bills of materials as we go that indicates what to use in the construction, and we're even starting to create operating instructions. All of this stuff requires operating instructions, manuals, detailed guides, instructions, etc. The result of this is a package of documents that that is given to the component vendors to provide their parts to the various contractors that provide the various subsystems. No one builder does it all. It's always done by multiple subcontractors, and then the person called the prime contractor that puts it all together. That would be Boeing, for example, for aircraft, or might be Newport News Shipbuilding for a submarine. So once that package is received by them, then they can start building. Now at this point, we start doing what's called design verification testing, similar to our evaluation step. So here we're primarily concerned with the subsystems. Do the subsystems meet the requirements, constraints, etc. that we've specified above? So we perform testing at this stage. What's interesting about this is that here we're developing detailed test procedures that will be used to do this verification, but at the same time we're also finalizing the manuals for operation of these subsystems. So they kind of go hand in hand. What I've seen is that we're writing the test scripts, but we're using what we learned from the test scripts to write the manuals, or vice versa, because those manuals also need to be verified that they actually do describe how to operate the equipment. Then the last step is integrating this all together into a finished design, an aircraft, a missile, a submarine, a surface ship, very similar to our presentation step. Now that it's integrated together, we can perform validation testing. We're primarily validating, does it meet those top-level user needs? For example, we might validate using sea trials. Now this is the picture there is of an aircraft carrier that is being towed out for sea trials. Perhaps the top-level military planners want an aircraft carrier that can achieve a certain speed or has a propulsion system with a certain output. During the sea trials, we will demonstrate that it either does or does not meet that. With aircraft, they might judge its agility and performance. These are the final things that we do before the product is either accepted or rejected by the military. So this is an example of the current military design process. Now this is called a V model. They went from a spiral, which is similar to our process, to what they call a V model, but you can see that the parts of our process map into it. So you'll probably see this V model if you work for the military or a military contractor. You might also see this in industry. This same model is currently very heavily used in medical device design. But again, the key points is we can map our process into it. And then the final thing, these are the references I used, and I want to thank Dr. Giachetti out at the Naval Postgraduate School for providing some information to me. That's it. So please have a very good rest of your day. And as always, email us if you have any questions, and we will see you later.